Hello everyone, welcome to this particular lesson. This is Primary 7, my name is Tr.Abura Ambrose. We are going to look at mathematics in this lesson and we shall continue from where we started the other day. Today we are going to look at how we can find area of irregular shapes. Irregular shapes are always got by joining two or more plane figures. So we shall look at how we can work out area of those irregular shapes. Now, we have a number of examples, but of course, in this particular video, I only look at 3 examples. So now, this is our first question. Work out the area of the figures below. Just like I said, we are going to have 3 figures. This is the first one. That's our number 1. When you look at this figure, the shape is irregular. You don't have any specific name for this shape. They have combined 2 different shapes to come up with this. When you look at this one here, the upper part here, this is a quadrant. And below the quadrant, they have put a semicircle. Now, for our candidates, they're always given this kind of question, and they say, work out the area of this. So when you're given a question like this, you have to take a good look at it, study it very well, and see which shapes are being joined to form this kind of figure we are having here. So in this case, if I look at it very well, we have a quadrant and a semicircle. So when they ask you to work out the area of this figure, you must work out the area of the quadrant alone and also work out the area of the semicircle alone. After working out the area of the 2 figures, you now add them to come up with the area of all of this irregular shape. So we are going to look at how we can work out the area of this. So now I will separate this figure into A and B. I'm going to name the upper figure A and then the lower figure B. In actual sense, our figure A is from this point up to the middle here, which is actually a quadrant. So I can work out area of a quadrant. Even below here is a semicircle, which I can also work out its area. So let's work out area of only the upper part, which is area of A. Area of A. And just like we said, our A is a quadrant. We already know the formula of working out area of a quadrant. Our area of a quadrant equals to a quarter pi r squared. A quarter pi r squared. Now, in this case, we have used a quarter because a quadrant is a quarter of a full circle. So our area now will be equals to a quarter times pi. In this case, we're going to use a fraction, which is 22 out of 7 times the radius. Now we have the radius. The distance from here up here is 28. Even this one here from this point to the other point is also 28. So our radius is 28 decimeters times another 28 decimeters. We have multiplied 28 by 28 because they're saying radius squared, which is same as radius times radius. So in this case, after multiplying like this, you now go ahead and reduce. So I can reduce, I say, by 7 is 1, by 7 I remain with 4 decimeters. And also by 4 is 1, by 4 is 1 decimeters. So now from this point, what will I remain with? I'll work it out up here the next step. We shall now have our area of that part A, which is a quadrant, S being 1 times 22 times 1 decimeter, then times 28 decimeters. In this case, now our area will be equals to 1 times 22 is 22. 22 times 1 decimeter, you get 22 decimeters. Then times the other side, which is 28 decimeters. So in this case, now I will remain with my area of part A, which is the upper S being 22 decimeters times 28. 28 times 22, you get 616. This is decimeters squared. Because decimeters times decimeters, you get decimeter squared. So this is our area of the upper figure, which is actually a quadrant. We have not yet finished working out the area of the whole figure. So after working out area of A, we also go ahead and work out area of B, which is the lower part, and in this case it is a semicircle. So area of B is now what we are going to work out. Area of B, and our part B is a semicircle. So how do I work out area of a semicircle? A semicircle is a half of a full circle. So that means our area will be equals to a half pi r squared. Pi r squared is the formula for the circle. So when I put a half, I get area of a half of a full circle, which is area of a semicircle. So my area now will be equals to a half times pi. We're still going to use 22 out of 7 times the radius. Now in this case, when you look at figure B very well, the distance from this point to this point is actually its diameter, not the radius. But we want to get radius. So that means if from here up to here is 28 because they are the same, but it is the diameter of figure B, that means I have to get the radius of part B. And our radius equals to diameter divided by 2. And your radius will be equals to the diameter, which is 28 decimeters divided by 2. And your radius will be equals to 14 decimeters. And that is the radius of the semicircle, which is below here. So from this point now we can continue and say this was a half times pi. Now times the radius, which is 14 decimeters, times another radius, which is 14 decimeters. From this point we can now reduce. You can now say this is by 7 is 1, by 7 is 2 decimeters. Then by 2 is 1, by 2 I remain with 1 decimeters. Then you continue. And your area now will be equals to 1 times 22 times 1 decimeters times 14 decimeter. And your area now will be equals to 1 times 22 is 22. And 22 times 1 decimeters, you get 22 decimeter. Then times the 14 decimeter. Now when I multiply this, our area will be equals to 22 times 14. You will get 308 decimeters squared. And that is the area of the lower semicircle. So that means we already got the area of part A, which is 616, and the area of part B, which is 308. That means to work out the area of the all of this irregular shape. I will now say it's to work out the area. I will now say it is equals to area of part A plus area of part B. And your area now will be equals to part A. The area is 616 decimeters squared plus the area of the lower part, which is 308 decimeters squared. So now when you add this, you can even add it vertically. But of course, if you add it vertically, you get the area of the irregular shape to be equals to 924 decimeters squared. And that will be the area of this irregular shape. So that's how we work out number 1. So we shall now leave that number 1. Please follow through and make sure that you always follow all of the steps. We shall now leave that number 1 and we look at another irregular shape, which is no longer now our number 1. So let's leave number 1 and we look at number 2. Okay, now let's look at our number 2. Number 2, when you look at this, is what we're going to look at. We have this figure, which has the shape, you cannot even mention the name, but they have actually joined two figures to come up with this shape. When you look at this very well, you will study and look at the upper part is a semicircle, then the part which is down is actually a rectangle. So when they ask you to work out area of a figure like this, study it very well and extract the different figures that have been joined to form this shape. So the upper figure in this case is a semicircle and the lower figure is a rectangle. So to work out the area of this question in number 2, you must now name the upper part to be A. Let's use X and Y this time around. The upper part is X, the lower part is Y. In actual sense, our X is a semicircle and our y is a rectangle. So you have to work out area of the semicircle, get the answer, work out area of the rectangle, get the answer, and add the area of the two parts to give you the area of this irregular shape. So we shall look at the area of the upper part first. Area of x. Area of the part marked x. And we said our x is a semicircle, isn't it? So if it is a semicircle, how do I work out area of a semicircle? We look at it in number 1, but we shall still do it in number 2 anyway. So our area of the semicircle in this case equals to a half pi r squared. And our area will be equals to a half times pi, we shall still use 22 out of 7, 22 out of 7 times. What we are seeing here, if the distance from here up here is 14, that means also this one which is dotted is also 14 because they are the same. So in this case, what we are seeing as 14 is actually not the radius of the semicircle, but it is the diameter. So we get the radius again. Radius equals to diameter divided by 2. Your radius will be equals to 14 meters divided by 2, and your radius will be equals 7 meters, and that is the radius of the semicircle. So you work out now and say a half times 22 out of 7 times 7 meters times 7 meters, and then you go ahead and reduce. We can now reduce this by 7 is 1 by 7, I remain with 1 meter. By 2 is 1 by 2 is 11. So our area now will be equals to area of that figure now will be equals to 1 times 11, 1 times 11, then times 1 meter, then times 7 meters. And your area will be equals to 1 times 11 is 11. And 11 times 1 meter you get 11 meters. Then times the 7 meters. And your area will be equals to 11 times 7, you get 77 square meters. It's the area of the upper semicircle. We already worked out the area of the upper one. Now our task is to work out the area of this lower rectangle. And we are aware, we learned this already from P3, P4, P5, even P6. So how do I work out area of the rectangle, which is area of y? Area of part y. Area of part y. And we already said y is a rectangle. Area of a rectangle equals to length times width. We just multiply the length and the width. So your area will be equals to the length is 14 meters times the width, which is 6 meters. So now when you multiply 6 meters times 14 meters, you get your area is equals to 84 square meters. And that is the area of the part marked y. Now in this case, we have got the area of x and the area of y. Now the task is to work out area of all of this figure. So that means to work out the area of all of this irregular shape, I'll say its area will now be equals to area of part x plus area of part y. And your area will be equals to, area of part x was 77 square meters plus area of part y, which is 84 square meters. So your area now will be equals to, when you add 77 plus 84, you can add it vertically, you will get 161 square meters. And that is the area of this irregular shape, where they have joined two different plane shapes to form this. So this is our example number 2. I'll only add one more example and then some numbers will get in the exercise. So this is our number 2. Let's leave this number 2 and we go to number 3. Okay, this is our question number 3. Remember, we are still looking at how we can work out area of irregular shapes. We have already looked at number 1, 2, and 3. Now let's look at this number 3. I mean, let's look at this number 3. Number 1 and 2 were basically joining two plain figures. But when you look at this number 3, there are 3 different figures you can see. There is one figure at the extreme left here, there is one in the middle, and one in the extreme right. On the left, the figure we are seeing is a semicircle. In the middle, we are seeing a rectangle. And on the right, this side, we are seeing a quadrant. So that means to form this irregular shape, they have actually joined 3 different shapes. So that means you have to work out each of this area of each of these figures, and then you add them in order to get the area of this irregular shape. So for this case, before you even start working out the area, you must look at the exact distance, the measurements. If the distance from here up to here is 14, automatically this is also 14 centimeters. But since we have a quadrant this side, that means also the distance from here up to here is also 14 centimeters. Now, also from this point to this point is 28. That means also the one down is also 28 centimeters. So this is now the measurements for almost all the sides of this irregular shape. So we can now work out area of each and every part, and then we add in order to get the total area. So I'll separate them. I'll say this first one is P, this second one is Q, and this is R. Our P is a semicircle, Q is a rectangle, R is a quadrant. So you work out area of all the 3 parts. So I'll start with area of P, which is area of this semicircle. Area of P, which we have already worked out. We have already worked out area of a semicircle in number 1, number 2, even number 3 we are still doing it, of course. We shall now be a little fast. Our area will be equals to a half pi r squared. And now area will be equals to a half times pi. We are still going to use 22 out of 7. Sometimes they tell you to use the value of pi, which is 3.14. So don't be a slave to 22 out of 7. Sometimes they change to 3.14. So this case now I'll have times 22 out of 7 times the radius. What we are adding is 14 in this semicircle is its diameter. So that means its radius is actually equals to diameter divided by 2, and radius equals to 14 centimeters divided by 2, and radius equals to 7 centimeters. So we can continue and say times 7 centimeters, which is the radius, then times another 7 centimeters. Then you now reduce where you can reduce. By 7 is 1, by 7 is 1 centimeters. By 2 is 1, by 2 is 11. So your area now will be equals to, when you are now working out, you will have your area equals to 1 times 11 is 11 times 1 centimeters times 7 centimeters. So in this case now our area, we shall continue from up here. Our area now will be equals to 11 times 1 centimeters. You get 11 centimeters times 7 centimeters. So when you work out the area of this semicircle, which is P, you will get 77 centimeters squared, which is now area of part P. Remember, we have to work out area of all the 3 parts. Then let's work out the area of part Q. Area of Q. Area of part Q. Our figure Q is a rectangle. We already worked out the area in part 2 of a rectangle, so we know the formula. Area of a rectangle equals to length times width. And your area will be equals to length is the distance from this point to this point, which is 28 centimeters, times the width is this, which is 14 centimeters. So your area now will be equals to, when you multiply 28 times 14, you will get 392 centimeters squared. So that is the area of part Q. Now we are remaining with part R. Area of R. Our shape R is a quadrant. So we shall work out area of that quadrant. Area of R, which is our quadrant. So area of the quadrant equals to a quarter pi r squared as area of our quadrant. So our area will be equals to a quarter times pi, which is 22 out of 7, times the radius, the distance from here up here is 14, which is our radius. So times 14 centimeters times 14 centimeters. So from this point you can now reduce the common factors. I will now have this by 7 is 1, by 7 is 2 centimeters. By 2 is 1 centimeters. And then by 2 is 2. Then by 2 is 1, by 2 is 11. So our area now will be equals to, when you multiply this, you will say 1 times 11 is 11. 11 times 1 centimeters to get 11 centimeters times 14 centimeters. So your area now will be equals to 11 centimeters times 14 centimeters, you'll get 154 centimeters squared. So we have actually worked out the area of part P, the area of part Q, and the area of part R. So now we want to work out the total area of this irregular shape. So we shall now add it, all of them. Add for P, add for Q, and add for R. So now total area of this irregular shape, I will now do it at this point. Area of this, I'm going to wrap this part. To get the area of the whole figure, I will now say its area of the whole figure will be equals to area of P plus area of Q plus area of R. And now area now will be equals to area of P is 77 centimeters squared plus area of Q is 392 centimeters squared plus area of R is 154 centimeters squared. So now you can add, you can start by adding this and that. So our area will be equals to, when I add area of P plus area of Q, I'll get 469 centimeters squared plus 154 centimeters squared. I started by adding this and that. So now our total area, when you add now area of P and Q and R, that is now 469 plus 154, you'll get 623 centimeters squared. As the area of our irregular shape, which is our example number 3. So for this particular lesson, we shall stop here, but of course our exercise will be given, which you can also download and do exercise which is related to this number. So I will stop here, and then we shall continue in the next lesson in another video. Thank you so much.